Hello everybody. I have another short video on how to find derivatives using the limit definition of radical and rational functions. So let's say we want to find the derivative of function f of x equals 3 over x. How can we use the limit definition to do so? So recall that the limit definition of a derivative, f prime of x, that's equal to the limit as h approaches 0 of this difference quotient, f of x plus h minus f of x, all divided by h. So we have the function f of x equals 3 over x. Let's set up this limit. The limit as h approaches 0. Well, what would f of x plus h look like? We're going to substitute x plus h into x. So that will give us 3 divided by x plus h. Now we're going to subtract f of x. F of x is equal to 3 over x. All divided by h. All right, so our derivative f prime of x is equal to this limit. We need to simplify as much as possible. And we'll do so by setting up and simplifying with a common denominator of the difference of 3 divided by x plus h minus 3 over x. So our common denominator would be x times quantity x plus h. Don't forget we're still dividing by h in the denominator. So what I've done here is I've taken 3 over x plus h. Let me get this 3 over here. I've taken 3 divided by x plus h, and I've multiplied the bottom by x. So to make sure that's balanced, I'll also need to multiply the top by x. I took 3 over x. I multiplied by an extra x plus h. So to make sure that we're still balanced, I'll have to multiply the top times an extra x plus h. And now because those tops are in like terms, I can combine them. As the limit as h approaches 0 of x plus h, 3x minus 3 times quantity x plus h. Still all divided by h. Now this is where we can kind of get confusing for some people. Rather than dividing by h, I'm going to multiply by the reciprocal. So I'll bring down 3x minus 3x minus 3h. We'll kind of expand that out a little bit. Divided by x quantity x plus h. Now, rather than dividing that by h, dividing by h is equivalent to multiplying times 1 over h. How can we simplify? Well, 3x's cancel out. These h's cancel out. That leaves me negative 3 times 1 divided by x times quantity x plus h. Now, if I go back to the previous slide, let's look at what we've done so far. Before I canceled out that h, I couldn't let h approach 0 because I'd be dividing by 0 in doing so. After I've canceled out that extra h here and here, leaving me what I have on the next slide, now I can substitute an h for 0. If I let this h go to 0, that's going to give me negative 3 divided by x times x plus 0, which is simply just negative 3 that a little bit better. Negative 3 divided by x squared. And there's our derivative. F prime of x equal to negative 3 divided by x squared. If you want to find the instantaneous rate of change at any point, or the slope of the tangent line, slope of the graph at any point, simply substitute that x coordinate into your derivative here. All right, so there's a good example of finding the derivative of a rational function using common denominators. We found a common denominator here in this step. The common denominator of x and x plus h is simply the product of x times x plus h. Make sure you multiply to keep your ratios balanced. We did a rational function. Let's look at a radical function. Say I want to find the derivative of y equals the square root of x minus 1. Now we have a radical function. This involves a root, a square root. The process is still the same. It's still the derivative. It's going to be given as the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. So let's set this up. Y prime equals the limit as h goes to 0 of, all right, so f of x plus h means to substitute x plus h in for this x. So that's going to be the square root of x plus h minus 1 minus the square root of x minus 1, all divided by h. Now the trick here is to multiply by the conjugate. And we'll do that here on the next page because it's going to require a little bit more room. The conjugate is we're going to multiply the top and the bottom and only change the sign of what's in the middle. So rather than minus root x plus 1, we're multiplied by the square root of x plus h minus 1 plus the square root of x minus 1. So equal to the limit as h goes to 0 of the square root of x plus h minus 1 minus the square root of x minus 1, all divided by h. Now we multiply by the conjugate. And that's where we're going to change the sign in the middle. So now it's going to be the square root of x plus h minus 1 plus the square root of x minus 1. And to keep it balanced, multiply the bottom by the same. All right, so let's start simplifying. Square root of x plus h minus 1 times the square root of x plus h minus 1. Well, those two radicals will cancel out, leaving me x plus h minus 1. The square root of x plus h minus 1 times the square root of x minus 1 is going to be plus the square root of x plus h minus 1 times x minus 1. Multiply this times this, the two inner terms, minus the square root x plus h minus 1 times x minus 1. Now I have negative square root of x minus 1 times positive square root of x minus 1. So that will be, if I can just kind of bring that down here. Actually, I think I can zoom out. Well, let's just put it off to the side. So minus quantity x minus 1. Still all divided by h times the square root of x plus h minus 1 plus the square root of x minus 1. All right, so what can we start canceling? Well, this looks terrible, so let's start canceling some stuff out. That's gone. That's gone. I have x minus x. That's gone. I have negative 1 minus negative 1. That's gone. That leaves me h on top. So let's kind of come to the next page and start writing this. Equals the limit as h goes to 0 of h divided by h times square root of x plus h minus 1 and what was the last piece there? Plus the square root of x minus 1. How can I keep simplifying any further? Notice I have an h in the numerator and denominator to cancel out. So equal to the limit as h goes to 0 of 1 divided by the square root of x plus h minus 1 plus the square root of x minus 1. Now we've actually done something rather important here. Before I canceled out the h in the line up above, could I substitute in 0 for h? No. I'd be dividing by 0 in doing so, and that'd be undefined. After I cancel out that h, am I allowed to substitute in 0 for h? And the absolute answer is absolutely. This 0 right here would not give me a 0 in the denominator. So this would be equal to 1 divided by the square root of x plus 0 minus 1. That's just x minus 1. Because once again, this is going to 0. So x plus 0 minus 1 is simply just x minus 1. Plus the square root of x minus 1. Well, if I have a square root of x minus 1 and a square root of x minus 1, and I put them together, now that's 2 square root of x minus 1s. So y prime is equal to 1 divided by 2 square root of x minus 1. And now we're all done. Some good examples of how to find the derivative of radical and rational functions using the limit definition. Hope this helps. We'll see you again next time.